Section 4.3, Distinguishing Among Atoms. So let's talk about first the atomic number. And all of the elements are different because each one has a different number of protons. So one atom has 5 protons, another one 6, 7, and so on. They're all different. None of them have the exact same number. Well, the number of protons is also what we call the atomic number. So we decide the atomic number based on the number of protons of an element. So if an atom has 8 protons, its atomic number is going to be 8. And you can see in this chart the first 10, and you see the atomic number, and you see the protons, and you can see that they're exactly the same. But notice neutrons, and we'll get to those later, but they're different. I mean, there's no real pattern between any of those. And neither is the mass. There's no pattern there. But then if you look at the number of electrons, you'll see that's exactly the same. So the atomic number, by definition, is the number of protons, but the number of protons is also equal to the number of electrons. So if you know one of those 3, you can figure out the other 2. So let's take a look at a sample problem here. The element nitrogen, shown here in liquid form, has an atomic number of 7. How many protons and electrons are in a neutral nitrogen atom? Well, we said before those were all the same. So if the atomic number is 7, number of protons, number of electrons, both would be 7. Take a look at this chart, and I want you to stop the video for a moment and fill in the chart on number 15 and then also do number 16. So take a minute, stop the video, and come back when you're done. Okay, so for A, should be 19. For B, the element is boron. The atomic number is 5, and the number of protons is 5. For the next one, for E, protons is 16, electrons 16, and the atomic number for G would be 23. H would also be 23. All right, taking a look at 16, how many protons, electrons are there? Well, in fluorine, atomic number is 9, so there must be 9 protons and electrons. For B, 20, must be 20 protons, electrons, and C, 13 protons and electrons. Okay, so we've talked about atomic number, protons, electrons. Now let's add in that last particle. And if we total up the number of protons in an atom and the number of neutrons, we get something called the mass number. So the mass number is the total of protons and neutrons in an atom. So if you wanted to figure out the number of neutrons, you're simply going to subtract the number of protons from the atomic number. So number of neutrons equals the mass number. I'm sorry, you're going to subtract the number of protons from the mass number, or the atomic number from the mass number in this example here. So the number of neutrons equals the mass number minus the atomic number. So let's say we were talking about something that had a mass of 19 and its atomic number was 9, and you'd say 19 minus 9, the number of neutrons would be 10. So here's an example. If we have gold, we can write this in this way. And the top number indicates the mass number. The bottom number indicates the atomic number. Sometimes they also write it as gold-197. So when they do that, they're writing out the name of the atom, and then they're writing out the mass number. And in order to do any calculations, you would have to look up or know what the atomic number is in order to do that. So if you wanted to figure out in this one, you would know the bottom number is the atomic number, therefore that's the number of protons, the number of electrons. And if you wanted to figure out the number of neutrons, you would need to subtract those two. And it's kind of nice, they line them up, so you just subtract down. So you'd say 197 minus 79, and what would you get? 118 for the number of neutrons. Alright, so in here, it says how many protons, electrons, and neutrons are in each atom. And if we look at beryllium, we know its atomic number is 4, its mass number is 9. So if we know the atomic number is 4, we know the number of protons and electrons are 4. The mass number tells us protons and neutrons, so we would subtract, and the number of neutrons is going to be 9 minus 4, or 5. So for B, protons and neutrons are going to be 10. The difference between 20 and 10 is going to be 10, so the number of neutrons is also 10. And for C, protons and electrons are 11, and the mass number minus the atomic number is 12, so the number of neutrons are 12. All right, take a minute and do 17 and 18. Okay, for A, should be 8 neutrons. B, 16. C should be 61. D should be 55. And E should be 125. 18 says use table 4.2 to express the composition of each in shorthand form. So they would want you to write them in terms of, like for carbon, you would say 12 over 6C. And for fluorine, it would be 19 over 9C. For beryllium, it would be 9 over 5Be. Isotopes are atoms that have the same number of protons but different numbers of neutrons. In other words, if you looked at our example that might have, back in that chart, it showed you an example of how many protons and how many neutrons something had. Well, it only showed you one example of that particular element. There are other examples. So there might be an atom that has 6 protons and 6 neutrons. That's pretty common. But there could be an atom that has 6 protons and 7 neutrons, or 6 protons and 8 neutrons. Those are known as isotopes. Now they're the same element because they have the same number of protons, so that makes them the same element. But they do have different masses because they have a different number of neutrons. So the simplest example is hydrogen. Hydrogen 1 simply has 1 proton. It's 1 proton, 1 electron. Hydrogen 2, on the other hand, has 1 proton, 1 neutron, and 1 electron. And hydrogen 3 has 1 proton, 2 neutrons, and 1 electron. And these are all isotopes. They're all examples of hydrogen. They're all hydrogen, but they all have different masses. So here's a picture of neon and some of its isotopes, and you can see that they have different number of neutrons, 10 in the first, 11 in the second, 12 in the third. So you have neon 20, neon 21, neon 22, just all examples. So an isotope, same element, same number of protons, but just different numbers of neutrons, therefore different masses that go on.